Welcome back, this is Key Skill 4. We're still getting into the sine rule. We've looked at the proof for the sine rule. We've looked at the ambiguous case for the sine rule. We've looked at a missing side for the sine rule, and this is the fourth and final video on the sine rule. So today we're going to be looking at what to do if you've got a missing angle, specifically a missing acute angle, an angle smaller than 90 degrees. If you've got an obtuse angle here and you're not sure what to do, make sure you've watched the video on the ambiguous case. So, to recap, when do we use the sine rule? Well, we need to have the partner of what we want to find. So if I want to find this angle, I need to have its partner, 8.5. So angle A matches up with side A, which would be between B and C. So you can imagine, you shoot the bullet, where do you hit? 8.5. So we need to have half a pair. Now, you need to have one full pair. So that's an angle and its partner. So in this case, if I've got angle B, I also need to have side B, which would be between here at C and A. So a full pair and the partner of what you want is what you need. All of these graphics were made in the GeoGebra app using David T's stuff. I talked about this in the previous example. Love it. Go check it out if you haven't already seen that. Look, it's got little hearts because I love it. So what do we do here? Well, what do I want to find? It always goes in the top left. So I want to find angle A. So I'm going to put sine A here divided by A. And the other pair I'm working with are the B's. So I set it up as sine B divided by B. So sines on the top, or angles on the top, sides on the bottom. So sine A divided by 8.5 equals to sine B. So I'm going to fill in the numbers now. 24 divided by 5. Move your 8.5 over here. That's a divide by. It's going to change to A times by. So type this onto your calculator. Use your fraction button. Sine 24 divided by 5 times 8.5. So that tells you what sine A is. So type in 0.69 ... Now to get from sine A to A, you need to know what's the inverse of sine. So you need to press shift sine and you get arc sine, or sine minus 1. And then use your answer key, because your answer key is going to get all of those decimal places. It's going to get you a really accurate answer. So shift sine here, and that gives you a final answer of 43.74 if you're going for 2 decimal places. Always check your accuracy. I've said that before. So easy peasy, right? Let's look at example dos, the second example in the fourth key scale. So here we've got a missing angle, it's A. So again, sine A. Which side is it partnered with? Well, it's partnered with 9.2. Sine 23 divided by 5. Okay, move the 9.2. Type it in. So sine 23 divided by 5 times by 9.2. So that's sine A. Just write a couple of digits and then a ... And to get from sine A to what is angle A, you press shift sine and the answer key. So 45 point, let's say 97. I'm going to go 2 decimal places, 2 dp. I can see from my diagram that A is acute, so I don't need to use the ambiguous sine rule. You see, you can see it's an acute angle. Don't forget, we talked about that before. If it was an obtuse, to get the final answer, you'd have to do 180 minus. So it would be like this. But our angle is little itty bitty, so it's acute. So that finishes up the key scale. In the final video in this series, we're going to be looking at the area of the triangle. We already derived the proof and explained where that came from. And now we're going to be doing one example with numbers. So stick around for that, and I'll see you in the next one.